All right. Hello, everybody. Today I'm going to be teaching a math lesson in the context of a science classroom. One thing that I have noticed in my student teaching, something that has come up, while I'm doing a lesson, I discovered that students are having a hard time with finding the average. So just being able to find the average of a data set, being able to look at a data table of the data that they have collected, trial data of just specific things that they've run trials on and the amount of times that they counted a certain, let's just say in this case it was blinks, it was blinks per minute. Um, they were not able to find an average, and it was only two trials that we had run, and I thought that it was pretty interesting to see that even with there only being two trials and the numbers being fairly small, you're not blinking too many times in a minute. I thought it was interesting that they were not able to find the average. And this is a sixth grade class, and I at least for me, I think at that age I felt like I was definitely able to find an average. In that regard, I think that it would be a really good idea for me to, be able to teach my science class some basic math. Some things like this, mean, median, and mode that would, be able to allow them to, analyze data better. Be able to find out, what the average is, where the middle of their data is, and also, what is the mode, which is, the where the majority or where the most of their data is lying. So I'll go through this together. I'm kind of going to be teaching it, along with the slideshow, so we can go together and see how. So today's objective is to calculate the mean, median, and mode of the lab data that we have collected. Eventually you want to be able to use sentence frames. You want to be able to say the average is of my data. The average should also be understood as being the median, or sorry, the mean, I should say. Uh, and in science, context, you would be saying, how your math is used to interpret the results of your data. How math can be used as a tool to be able to understand your data better. I think that's important. Math is all around us, and being able to use math in a real world context, I think is really important. And I think science, is really benefited by you being able to understand math and having just kind of some of these basic math principles. Being able to know the average of things is really central to a lot of scientific data analysis. I'm, really wanting to hopefully, make this point known to my sixth graders when I do eventually teach this lesson to them. So I want to try and make sure that I'm hooking them. So I would probably, in this regard, come up with a way to, bring up the fact that we had this gap in their knowledge and talk about, hey, the average was something that I recognize that you guys were not aware of, but I think it's something important moving forward for when we are collecting data that we are able to find that average. And we can do it quick. It's a very nice, easy thing that we can do. We can use calculators even, add up all your trials, divide by the number of trials that you had. So that type of knowledge should be second nature. So I want to make sure that they're able to kind of figure that out. So the hook would be kind of reminding them of that knowledge gap that they had. The recent experiment and lab trials that we had that they kind of seemed like they weren't really knowing how to get the average, and reminding them, hey, this is how we can do it, and it can be something very simple and easy and fun for you to be able to figure out the average of your lab data in the future. So we'll just say, for this, there was, 22, in this case, I put drops, but it could be, blinks per second. It could be, dropping a ball, could be throwing a ball. It could be anything that, is just data that we're collecting here. And then also, why aren't, all of these drops the same? So how does the variation within these drops also, affect the overall outcome or the results of our lab? So the variation is, just a part of life. So gravity is going to be affecting, say dropping a ball, the what you're reading, or if you're focusing might affect the number of blinks that you have. And then there also could be potential for human error as well. So you might see some data that is going to be really, really high or really, really low. So then that's where average kind of comes in, and it's able to kind of figure out where that middle ground is. So it kind of makes up for any variation or any human error. So then that way you're getting pretty much just the basic average of where everything's at in terms of data. So the mean or the average is just the sum of all of your trials divided by the number of trials. So you add up all of your trials that you have. So whatever numbers you have, whether it be 25, 28, 22, add up all those numbers. So just simple addition. And then once you have that addition done, then you just divide by the number of trials that you have or the number of numbers present. So if you have 25, 22, 28, then there's three different numbers there. So you would divide by three once you have your addition completed. So for ELs, in here in California, we have a lot of Spanish speakers. So the word average in Spanish would be promedio. So promedio, average. That's the same word. Average and mean, they mean the same thing. Average and mean. I'm not sure why exactly it's called mean. It's kind of a mean thing to do. They should have just maybe called it average from the get-go. But it's basically just a way for you to be able to understand that average and mean are the same thing. Basically giving you the fair share, if you will. It's the middle point based on the number of highs and lows, and it finds the exact middle point. Sometimes it might even be a decimal to get it exactly right in the middle of where numbers are. Now, switching gears, we're going to switch to the median. So a great way to be able to understand the median. You can kind of think of a real world example here is the median in the middle of a highway, right? In the middle of a road. So I'm sure students they know and when you're driving down the freeway, there's a little middle part, right? That middle part is the divider between one side and the other, and that goes down the middle of the road, right? So if you kind of think of median, middle, hopefully that gives you a little bit of word recognition, so then that way they can remember that for assessments and things like that. So really all you have to do for that, you're just ordering your data in the least to the greatest. So if it's 22, 25, 28, then the number that's directly in the middle based off of your data, that's your median. So in this case, for those three numbers, it would be 25. So pretty simple. You're basically just kind of, the only thing that you really have to do is just kind of put all these numbers out on the line and order them from least to greatest and just find that middle point. If there's two numbers that, are very similar, very close, that are right in the middle, then you might have to find the average between those two. But the median would be wherever that middle point is. Now, for the mode is really the most popular, right? So that's a great way to remember it. Mode, most popular. It's the value that appears the most often in your data. So I'll give an example after we get past this, but the mode is really the number that you're seeing the most often. So if we're looking at a number of let's just say trials that have let's just say 22, 21, 25, 22, 28, 27, 22. Then the number that appears the most often is 22, right? So we saw that number appear three different times, even though there was a lot of different trials. We want, to pick 22 as our mode. That is the one that is appearing the most often, and it's, going to be potentially the most valuable number of, data when it comes to, running trials. 22 might be, what is actually the correct number, depending on how many trials that you've run. Sometimes there might be some variation, like we were talking about, human error variation. A lot of times that mode is going to find where the correct number is going to lie. So a good way to remember it, mode and most. So they both start with that MO. So if you just kind of remember that mode and most, you can also think of it as being the popular one. That's the one that shows up the most. And also another thing for Spanish, since we're here in California again, Spanish cognate would be la moda, right? Moda is fashion or trendy, popular. You can kind of think about, I got Ariana Grande here singing her popular. So if she's popular, she's focused on being the trendy one. It's the one that is appearing the most often. So here I would like to run some guided practice. So for the data we have here, it's 21, 25, 22, 25, 27. So with some guided practice, I want to go ahead and put these numbers actually, on a whiteboard here. So if we're going to figure out the mean first, the mean is adding up all the numbers. So 21 plus 25 plus 22 plus 25 plus 27. So if we got them all written out like that, make sure I can get it on the screen there. So put all the numbers down, get your plus sign there, and then we're just going to do some basic math. So if you put all those numbers, add them all up, 1 plus 5 is 6, plus 2 is 8, plus 5 is 13, plus 7 is going to be 20. So you put the 0 down at the bottom, and then carry over the 2. And then now we just add up all those 2's. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10, plus 2 is 12. So we got 120. So there's some basic math for you, 120. Now, if we were going to divide by the total number of numbers that we have here, there are 1, 2, 3, 4, 5 numbers. So that's 5 pieces of data, 5 trials, just 5 numbers that we have used here. So anytime that we're figuring out the average or the mean, then we would divide our total, or sum that we have added up, by that number. So if we only had 3 numbers, we would divide by 3. Since we have 5, we're going to divide by 5. So simple division problem. Write it right there. 5 into 120. 5 goes into 12 2 times. So then we put down your 10 there. Subtract, you get another 20. So then 5 goes into 20 4 times. No remainders. So we are done. So our average for this set of data would be 24. So yeah, so that would be, about the middle point of all those sets of data. Since 25 is the mode here, that sounds about right. It's pretty close. We have some outliers like 21 and 27. The middle point is that 24 there. So let's go ahead and now work on finding the median. So median, as I was saying before, is the middle. Median is the middle. I'll put middle here so you guys can see that. Median or middle, right? So if we put all these numbers out on a number line, we've got 21, 22. Remember, we're ordering them from greatest or from smallest to greatest, just like so. So you always have to make sure that your numbers are going smallest to greatest. 21, 22, 25, 25, 27. So then by doing that, then you just find the middle number. Since we have an odd number of numbers here, your middle number is very easy to find. It's 25. Boom, your middle number, nice and easy. So you can say the median of our data is 25. Perfect. Now, with mode, as I was saying before, mode is just the number that is the most popular, the number that appears the most, right? Most, mode, or popular. It's the mode, the one that happens the most. All right, so then now we've got our 21, 22, 25, 25, 27. Now looking at these, what number appears the most? Yeah, 25. So we can go ahead and circle our 25s. That is our most. That is the number that appears the most, or our mode. So in science, this might point towards the true result, the true number that we are looking to achieve. Some of these, outliers that we have, like 21 here, or maybe 27, those might be less accurate data. Less accurate data. 25 would probably be the most accurate if we're looking at this from a scientific perspective. So, whatever number appears the most potentially could be, your best number. So now that we figured out our mean, our median, and our mode, our number is pretty close. So our mean was 24, our median and our mode were both 25. So, with that being said, we pretty much have a, pretty, I would say, justifiable reason to believe that the correct number or right around the correct number is about 24, 25. It really gives us a good direction about where our trials are heading. And then, if there are going to be any subsequent trials, then we can use that data to help kind of build our knowledge and build our base for the next time that we're running trials. Because say the next time we run trials, we start getting like 45 or 55. We're like, what the heck happened? Because, the last time we were getting 24, 25 on average, or our mode was about 25 last time. Why are we getting 50 this time? And we can start to look at those variables and things and maybe see some variations and things that are, causing that particular spike, if you will. So from here, I would like to go ahead and pass out some independent practice, and I'll have you guys work with your partner, and we're going to go ahead and give you some data sets. So, potentially some numbers that you might have seen before, maybe some numbers that you haven't seen before, and just give you a chance with your partner to be able to figure out all three for all these different data sets that we get. So best of luck, and